that brings me to something I wanted to show you all today. I have a little video of sodium in water. And sodium, if you remember, is number 11 on the periodic table. So it's that first column way over on the side here. And it is an alkali metal. So here we go. It's put into water. And here's the slow-mo of that. Remember, the alkali metals were the most reactive metal group on the periodic table. And this is one up at the top of the group. So this is one of the less reactive of the group. And I will show you, let me just show you one more time at the beginning here. Pause it when they, so you, oops, I thought I'd be able to see the actual metal. No, it won't pause, but you see the metal there is nice and shiny and metallic before they drop it in there. So yeah, how many valence electrons does group 1 have? And hello, Edward. Group 1, how many valence electrons are in group 1? That's group 18, sorry. Group 1. Oh, yes, definitely refresh if you can't hear me. So how many valence electrons in group 1 for sodium? I'll give you a hint. Let's see. Group 2 has 2 valence electrons. So group 1, yeah, it has 1 valence electron. And so in order to react or form an ion, it's going to lose that 1 electron. Since it only has 1, it's very, very easy for it to lose it and react like that. So you can't just have raw sodium sitting around. You actually have to keep it under oil. And it's not allowed in schools anymore. I'm just going to remind you about our park. To participate, attend, read, and complete assignments. I'm going to focus on participate is going to be our next focus. Earlier today, I started calling students during class that weren't participating. So that was kind of fun. And we'll also thank you for your excellent code of conduct in class, always being respectful and courteous, not sharing any personal information. And hello, Jordan and Edward, Benjamin, welcome, or Ben, and Tyrese. All right, so we have our first EOC practice question from the Department of Education that creates the EOC. So this came straight from them, and we're going to use those emojis right down there to answer. So the elements neon and argon are not reactive. Which hypothesis best explains this? Hello, Zakaya. All right, and if you need to use the periodic table, it's right down there. And if you click the little person in the corner of the image box, it is a maximize me. And then if you click it again, it will minimize it back down there. So even if you don't have your own periodic table printed, you can use the one that's down there in the images. All right, we're doing pretty good. I'm just waiting on a couple more answers. So Ben, Jordan, Michaela, Porter, what do you think? And remember, I got this red X down here. So if you're really confused and you just have no idea, that you can pick that as well. And that way you can still participate if you can't choose between the 4 answers. All right, and annotation wasn't working earlier, so I'm gonna just talk about these. Thank you, Michaela. And hello, Nick. How are you doing today? All right, so neon and helium, if you found them on your periodic table, or neon and argon, you can see that they are in group 18, right? And so how many valence electrons do the noble gases have there in group 18? All right, Tamara's going with 8. Anyone want to agree or disagree about the noble gases having 8 valence electrons? Yeah, you are correct. They have 8 valence electrons. And so does that make them stable or unstable? Yeah, it makes them very stable. That's why they have the name noble gases, because they stay kind of off to themselves. They don't react with anybody or any other elements. So we can get rid of smiley face because it says that they are not stable. So smiley faces, you guys can change your answer to something else. Do you think neon and argon are readily available? Well, you know, we have neon signs, so they use it in that. Argon is also used in those neon signs, and they use argon to put sometimes between the window panes as an unreactive gas in between to help with insulation. So okay is not good because they are readily available. And we just said that they had a full electron level, 8 valence electrons. So they're not going to give those up. And so turtle is the right answer. They have a full shell, like the shell on the turtle. So once you understand the question, make sure you give me the answer, because you can change your answer there. And that way I know that you understand the right answer there. Can you all see what your emoji is? When I logged in as a student, I couldn't see what my emoji was. Okay, so you can see your own now, because that was a couple of weeks ago when I was practicing. And hello, Amir. All right, moving along. Yes, these are noble gases, full valence shell, non-reactive. So today is Friday, and on Fridays, we're gonna have a graded assignment. And so this week, we're doing a discussion, and we're gonna kind of take everything you've learned so far and wrap it up into a discussion post, because next week, we're gonna kind of start a new topic and move away from the periodic table for a little while. So we are obtaining, evaluating, and communicating information from the periodic table. And we're going to talk about the properties of elements based on their location and their structure. And my goal would be to have you walk out of here today with this assignment complete. That is my goal. So we've got 2 websites to pick from. The element description and uses looks like the periodic table. You click on the element you want to look at, and then it's got information, and then you can click from there to go other places. The interesting engineering kind of has everything all on that one page, and you have to just scroll down. It's more like just a web page or a blog where they've got hydrogen information and then helium information. And so how do you get to this discussion? Where do you think the discussion's located? Yeah, it's in Canvas. And I'm not sure if I put a module in for today, but I'm going to show you really quickly here how to find it. So I think I found an easier way to put the discussions. So if you want to start pulling up your Canvas, you are welcome to minimize this and you can just listen to me. Or if you want to watch, then you can watch. So sharing. So I am logged in as a student. And so once I found my physical science class, over on the menu here, I added this button for discussions. So you just click on the discussion button. And there is today's elemental discussion. And voila, there it is. You can also get to it from the calendar. Let's see. Of course, this is my calendar, so it looks a little bit different, but there it is. It's at the bottom of today's date on the discussion. I think it's easier to do the that tab. Amir, I would like for you to write in sentences, but we don't particularly have a length that it needs to be. This is meant to be completed during class. Maybe not the replies, but the getting your answers to the 6 questions. And most everybody at least got through 5 and was working on 6 last period. So if you are ready for a breakout room, you can give me a green check. And if you want more help, then stay here. Look at that, Tamara. Hello, how are you today? All right, so again, if you go to the breakout room and you want to come back out, you just hit the X in the title of the breakout room and you come right back out. And I just wanted to take a minute and for the recording, at least if you're watching this on the recording, and show you the websites. The first website has a periodic table, and then when you click on an element like molybdenum, it'll take you down to the information about it. It tells you some properties. And then if you click on like armor plating, it can take you to some more links that would help you learn more about that. The other website is more just, like a running list. And so as you scroll down, it has the guide there what the colors mean. And then like it's got everything about hydrogen here, where it's used. And then it has a supporting video. So those are your options. You can look at both of them, or you can just look at one or the other one. And there's my bring everybody back. Hey guys, welcome back. I wanted to check in here the last couple of minutes and see if you had any questions or comments. What question did you struggle with the most? Okay, with number 4, the properties based on the location. And the best way to think about that one is really to kind of look at whether or not it's a metal, a non-metal, or the metalloid. And that first website Yeah, the first website gave you some properties in the list there. And okay, so you picked nitrogen. Oh, just getting your ideas down on paper. All right. Anyone else have any questions or want to tell me which question you had the most trouble with? I would love to hear your input here at the end. Hey guys, give me a green check if you finished your post. Not necessarily the replies, but that you finished your post. Excellent. And thank you, Red X, if you're still working on the post, would be fabulous. Cool. Thank you, guys. Good. It looks like we're about half and half, about half finished and about half still working. So hopefully, if you're still working, you're getting pretty close to number 6. And if you have any questions, remember I'm here to help. So if they come up later in the day, you can always send me an email or you can try giving me a call. As long as I'm not in class, I will definitely answer the phone. And I would love to be able to help if you need some help. And I guess that's about it for today. Happy Friday. And thanks for coming in and have a great weekend.